let's get going. All right. So there it is. For the graph, determine the value of. All right. So what do they want us to do on this problem? So I'm doing your homework. Here's number 1 on 2.3, and they got these dots on the graph, and they're asking. First question: what is f of? Remember, that doesn't mean times. That means of. F of -4. So that means they're plugging -4 in there, and they're wanting some answer. Well, how do you do that with a picture? What are they talking about? Well, the whole thing is, this is not hard. It's just like if you know the language they're speaking, it's cake. Basically, this is x, and what comes out is y. That's really all you need to know. What you plug in here, what's in the parentheses, is x, y. Well, because we always say f of x, don't we? So that's x that's being in the parentheses, and the answer that comes out will be y. Okay, so what does that do for me? Well, that means go to the x-axis. This is the x, this is the y, right? Go to the x-axis and find x -4. Because that's what this says here, right? The x value is -4. So where's x -4? Right here. Here's x -4. Go straight up, find the dot. That would be this dot right here. This dot is at what height? Go over. He's at a height of 5. That's the answer. There's nothing to do other than read it off the graph. In other words, maybe another way I could say it that would be more helpful. What is the coordinates of this dot? He's back 4, up 5, isn't he? He's back 1, 2, 3, 4, up 1, 2, 3, 4, 5. His x is -4, his y is 5. So they're saying find the point that has an x value of -4 and tell us the y value that goes with it. That's what they're saying on that question. Does that make sense? So when they put the -4 in the parentheses, they're saying x is -4, because whatever's in the parentheses is x. So they're saying among all those dots, which one of those dots is at an x value of -4? Well, this one. Okay, and what's his y value? What's his height? 5. That's the answer. So what you need to know is whatever goes in the parentheses of a function is x, and whatever it equals is y. So it's just reading that dot off the graph. Let's try, that's part A. Let's try part B, which asks for the domain. What's the domain? Well, here, wait, before I go on, let me make up another one to make sure that we're all good with this. What if they asked me, let's say, I don't know, f of 1. So don't say it out loud. Give everybody a chance to try to figure it out. What if they had asked me that? Try that on your own papers there. Find f of 1. So remember, this is x, and this is y. So they're saying find the dot that has an x value of 1. Find the dot that's over 1. So that's this dot right here, right? That dot's over this. That dot's at this. See how this is an x value of 1 right here. Good to there. So that dot has an x value of 1. What's his y value? Can you all see it? Is it too small? Question, comment in the back? Yeah, A was 5. You might have a different question or different dots. Yeah, randomizes it for everybody. For everybody's a little different. So it is 4 here. Is everybody seeing that? When x is 1, this dot is over 1, up 4, isn't it? So the y value is 4 there. Is that good? Is that making sense? All right, let me, we'll go on to part B. They want the domain and then the f figure. Okay, try. Let me give you one more. Find out what is f of -1. Don't say it out loud. Give everybody a chance. Let's try one more. Maybe you can see that a little bit better. Find f of -1. So remember, this is x, and we're looking for y, right? So which dot is at, this is the x-axis here, is at an x value. Well, this is x negative 1, so it's this dot. It's the very bottom of the v, isn't it? Is that dot right there? He's at an x value negative 1.
Yeah, it'd be negative 1, 2.
And so, yeah, he's back 1 up 2. And so what's his y? Well, it's 2. Is that making sense? Let's just find the dot.
It really doesn't make sense, but I get it.
What's that?
The domain?
Yeah, I haven't done domain yet. Let's go on and do domain. That's part B. So domain. So what is domain? Domain is the width of the graph. Well, the width coverage. The width coverage of the graph. So that's part B now. So in part B, what they're saying is, what's the width coverage? What's the domain? What's the width coverage of this graph? Like how far left, how far right, at which locations do we find graph? Do we find dots? Well, I see at negative, the places I see domain here, dots, are at negative 4, negative 3, negative 2, negative 1, 0, 1, and 2. At all those, so that's the answer. It's negative 4, negative 3, negative 2, negative 1, 0, 1, and 2. It's all, well, I think they want curly brackets. Let me go back. How do they phrase the question? They're going to give you curly brackets. So there it is. That's exactly how they want the answer, like that. So you just list the locations where you have dots. Just the x values. Nothing to do with the y's. Notice I did not even think about how high those dots are. I just thought about where they are sideways. Their x positions. From negative 4 to positive 2. Those are the domains. And then likewise, they're going to ask us, might be part D, I don't know, we'll get to it. But they'll say, what's the range of the graph? The range is the vertical coverage. The range is the up and down vertical coverage. So, to do range, if I can erase this now, range is asking the question, on the y-axis, how high and how low does the graph go on the y-axis? How high up, how low down, how far up and down are there dots according to the y-axis? That's range. Range is up and down, domain is sideways. So range is y values, domain is x values. So, well, which heights do we have dots at? Well, right here we have at 2. Here we have dots at 3. We have dots at 4. We have dots at 5. It'd be 2, 3, 4, 5. Those are the heights, the y values, at which we have dots. 2 through 5. 2, 3, 4, 5. Does that make sense on that? 2, 3, 4, 5 are the heights at which we've got dots. And so that's domain, that's range. Is that good? Is that making sense? So domain is the x values, range is the y values of the dots. And then they're going to ask, part C is any x value for which f of x is 5. So final question, x values for which f of x equals 5. So what x values make f of x equal 5? To answer that question, you've got to realize that, remember, anything plugged into the parentheses is x, that's obvious, it just says x. And whatever's outside is y. So that's y. So they're basically saying, go up there, look at that graph on the y-axis at a height of 5. Where's that? Right here. So that's this dot and this dot. They're both at a height of 5, a y value of 5, aren't they? So it's all about, all these questions are all about remembering x is inside the parentheses, y is whatever comes out. So at a y value of 5, at a height of 5, the two dots that are at a height of 5, what are their x values? What are their x values? Well, this one has an x value 2. This one has an x value negative 4. So the answers are negative 4 and 2. Either order, you put the 2 first and the negative 4. Doesn't matter. Those are the two x values that have y values of 5. Making sense on that? It's all graph reading. Questions I can answer? Good. All right, I'm going to flash off that. Okay, so the first question is, what is f of -1? Try that one out. This time, instead of dots, we actually have a solid line, which means what? Millions of dots, right? That's what a line is just all millions of dots all filled in there. So find the one dot that is at -1. What do I mean, at -1? Well, you tell me. Is this right here an x or is it a y? X. That's the crucial thing to remember. Whatever's in the parentheses is x. So they're saying find x -1 and tell us the y. That's the key. That's the key to reading the graph. Inside the parentheses is x, what it equals is y. So they're saying find the dot at an x value of -1 and give me the y value of that dot. So that dot's right here, isn't it? So they're not highlighting the dots now. It's just a solid line, which is millions of dots. We just have to locate it ourselves. Do you see why I went there? Because that's an x value of -1. Everybody see that? That's x value, x-axis, back 1. That dot. So I just go, okay, go to the x-axis, go back 1 on the x-axis, -1. Find the dot there. What's the coordinates of that dot? Back 1, down 2. So what's his y value? -2. -2 is the answer to the question. Everybody see that? Mm-hmm. So x -1, y -2. So we got that dot. And then, everybody okay with that? Yeah. And I'm probably covering it up here too. Yeah, it's because the coordinates of remember, there's millions and millions and millions of points, all along here. I'm grabbing the one point that has an x value -1. So if I go back 1, where is that? That's right here. That dot is back 1. Any other, like this dot, this dot's over 0. This dot's over 1. This dot's over 2. You know, the other dots are not back 1. That's the only dot that is back 1, is this one. And what's his coordinates? He's back 1, down 2. So the x value -1, y value -2, x value, y value is the answer. All right, next question, next part of this question asks, what's the domain? So let's try this again. So what's the domain? Remember what domain is? Domain is width covered, sideways, x's, and range is up and down, y's. So domain is sideways. So you come in here and you go, okay, sideways. So basically it's left edge, comma, right edge. And you're going to put parentheses around them. Left edge, comma, right edge. What's the left edge? How far, here's the domain here. How far left does the graph go? Well, this is left edge. Here's his right edge. The left edge is what? -5. The right edge is +3. So -5, +3. From -5 to +3, that's the domain. That's the width. Now, if I was you, I'd be like, no, wait a minute, Sharon, we didn't do that a minute ago on that last problem. Last problem, you had us list them out, right? You did like -5, -4, -3, -2, -1, 0, 1, 2, 3. Why'd you do that in the last problem, and this problem we're suddenly just putting the parentheses with left, right? That would be a great question if that's in your mind. Difference is this is a solid line, and that was dots. Do you see the difference? Let me go back here. Right? See, this was dots. So it would have been wrong for me to say, look, it's everything from -4 to +2. No, it's not. There's all kinds of holes in between. It's not all the numbers. If it was a solid graph like this, so it's not all the values from -4 to +2. That's why the answer is not -4. When you write two numbers with parentheses like that, you mean all the numbers from -4 to 2. Like even numbers like 1.5 and 1.3 and 1.9 and 2.6 and that's not right. It's not all the numbers. It's just dots. So it's just the whole numbers. It's just these. It's just the whole numbers from -4 to +2. It's skipping all the decimals in between. Whereas this one, right here, this is everything from -5 to 3. So we write it that way, and this would be incorrect. See the difference? Okay. Now, why do we use, do you guys know what those open dots mean at the ends here? This open dot and that open dot? As opposed to if they made them solid. Have you seen that before? Do you know what that difference is? Open dot, it's just like a drill, they just drilled the holes out, meaning it doesn't quite hit the ends. There's holes right there. It doesn't quite make it. If they made them solid, then it would include the endpoints. But if they make it hollow, then it doesn't quite include those endpoints. That's why I put parentheses. Did we talk about that Monday? I can't remember. Parentheses mean you don't hit the ends. Brackets mean you do. We didn't talk about that. I think in my other class, I get confused. They're very similar. So, yeah, if you have brackets, let me write that then. Brackets mean you hit the ends, and parentheses mean you do not hit the ends. You only get close. So we want parentheses on this one, not brackets, because of the open dots. Open dot does not hit the end. It gets close, but it doesn't quite hit 3. And this one doesn't quite hit -5. Open dots. Open dots mean it doesn't quite hit those ends. It just gets close. So that's why we use parentheses. We're saying all the numbers from -5 to 3 from left of -5 to right of +3, but not including the -5, not including the 3. It doesn't quite hit 3. It does 2.99999, but not quite 3 on the money. So it's rounded. It's around 3. It's close to 3. If you put a bracket, you would be saying it hits 3 right on the money. And that's not right. It doesn't. There's not a solid dot there. All right, that good so far? And then there's a couple other questions. What else is there? And if that's okay, I'm going to start it over. Question. This is all the same question here. They are saying f of x equals -2. Find x. Find x so that f of x equals -2. So how can we do that? Find x so that f of x equals -2. Let me let you do that. Oh, that's the same thing. That's kind of a dumb question. I don't know why they did that. Do y'all see it's the same point that we did? It's the same point right here. I wish they would have done a different point so we could learn something new here. But anyway, so that's the same dot. They're referring to the same dot because remember, this is x, obviously, and this is y. So they're saying find the x value that goes with a y value -2. Well, that's that same dot. That dot is back 1, down 2, like it was a minute ago. So the x value -1 goes with y value -2. That's what a graph is, by the way, is a bunch of connections between x's and y's, a bunch of dots which relate an x and a y, an x and a y, an x and a y, right? That's what a graph is. So the answer then, what is the x value? Well, it's just -1. Final question. They're going to say, what is the range? So let me let you do that. Find the range of that graph. So range. I don't think I said it clearly this way a minute ago. Let me say it clearly. It's from the bottom to the top. Just like domain is left to right, range is bottom to top. Yeah, I should have said it that way before. So that's how you want to think about it. So the range is here, and it's from the bottom, which is here, to the top, which is here. It's all, but these are open dots, aren't they? What did I just do? Something bad. These are open dots. So I should have done that a little more correctly. Open dot, open dot. Right? See how that's the range? So the range goes from -5 on the bottom to what, 1 on the top parentheses? Because again, open dots, it doesn't hit those right on, like that. Is that good on that? Is that making sense? Questions on that one? Are we good? All right. Let's try this one. Okay, so same thing. Let's start with, let me pick something different that'd be more interesting. Yeah, let's do f of 4. Yeah, let's do f of 4. So try that one.
What's that saying? When x equals 4, y equals...
What? Yeah, don't say it out loud. Give everybody a chance. But that's right. Yeah. That's right. The key is remembering that whatever's in here is x, and whatever it equals is y. Exactly right. So look on that graph. Find the dot, the one location that is x4. Find that dot, and find the y value of that dot. So when x is 4, here's the x-axis. When x is 4, go up to the graph. Boom, right there, huh? That's over 4 up 8, isn't it? So y is 8. Good? Is that making sense? So you just find the x value that they're giving you, and then give them the y value that goes with it. Okay, next, let's do domain. Now, for domain and for range, notice this one's different because it has arrows. What does that mean? Well, it means it goes forever up and to the right, forever down and to the left. So this graph's going to just keep on going up, and away like Superman, and down, down, and away. So it's gonna get forever high and low and forever left and right, isn't it? So what's domain supposed to be? Left edge, comma right edge, and remember we'll do range also. And range is always bottom, comma top. Okay. So what is the left edge of this? How far left does this graph go? Well, forever left. You know how to say forever left? Yeah, negative infinity. And how far right does this? Well, forever right, regular infinity, huh? Does that make sense? Right, there's infinity symbol, right? Because you can keep drawing it forever. It just keeps going, that 8 circle thing. And then range is bottom, bottom to top. You can't reverse that. The order matters. Bottom first, then top. So what's that? Same thing. It's forever down, negative infinity, to forever up, positive infinity. There it is, just like that. We good on that one? It's because of the arrows. Everybody see the difference? It's because of those arrows that it goes forever up and down, left and right. Whereas like the last one, see how this did not have arrows on the ends? It had open dots. If those had been solid dots, I would have had brackets on the end of all my answers instead of parentheses, right? Because a bracket is it's got a straight edge, means you're right on it, right? But this had open dots. I wasn't on it. I was just close to it, so we had parentheses. Making sense? Getting all. Try this one, number 5. Still in section whatever we're in, 2-3. So all right, they're asking what I forgot what are they asking? F of 2? F of 3? What it was? F of 3. Okay. So what's f of 3? Try that. Let me give you a second. F of 3. So remember, this is x, and the answer is y. So when you go to an x value of 3, it's right here. We're talking about this. This is the one dot that is over 3, huh? So that dot is over 3 up 2, isn't it? From the middle, that dot's over 1, 2, 3, up 1, 2. Right? So the answer is 2. That good? And then they want domain. Now, this is a bad question. MathXL did a bad job here. They really mean to put arrows on the end, and they forgot to. So I wouldn't put it on the test like this. I would be clear. So pretend they put arrows on the end. So what? Because that's what they mean. That's how they indicate the answer. So what would be the domain then if they really put arrows on the end? Yeah, left edge, right edge. Remember, domain's always left edge, right edge. Negative infinity to positive infinity, right? Forever left, forever left, forever right. Same thing, oh, well, no, not the same thing. A little different. Let me let you figure that out. What would be the range? Let me give you a second. Try that. Remember, range is bottom, comma, top. Give everybody a chance there. Try that.
Well, for the domain, okay, I'm on this one, like, for the domain, they want me to use the right kind of brackets, so since it's infinity would be brackets, or would be parentheses.
Infinity's always in parentheses.
Okay.
Yeah.
Oh my God, this is.
So it is just like that.
Yeah, it's mind-boggling my mind right now.
So what's the bottom of this graph? What's the lowest this graph? Now remember, with range, we're thinking heights. We're not thinking left, right. We're thinking up, down, right? So I'm thinking oops, about this axis right here. I'm thinking, how low does it go? How high does? Remember, these are arrows. So it goes up forever. That's clear, right? The top is infinity. But what's the bottom? 0. And does this right here have an open dot? This is the bottom right here, right? That's the lowest the graph goes. Is there an open dot there? No. So that means it's solid, which means this has got to be a what? Bracket. Bracket 0, comma, infinity, parenthesis. Why? Because remember what a parenthesis means again? You're around about it. You're not right on it. And a bracket means you're straight on it. Right? You with me? Right? We're straight on. This is straight on a height of 0. Straight on. It's not just an open dot there. It hits 0 height right on the money. So we need a bracket by the 0. But this graph goes up forever to infinity. Infinities always get a parenthesis. Infinity always get parentheses. Never a bracket. Why? Because you can never be right on infinity, right? You can never be right on infinity. You might go to the doctor, say, I waited forever. But you didn't really wait forever. You just started approaching forever. Right? You can never be right on infinity. So we never put a bracket by infinity. Always parenthesis. Does that answer your question, Renee?
Yeah.
That good? So there's the answer for the range. Bottom, comma, top.
We covered this like 2 semesters ago.
Did we? Did we do some of this stuff?
Not year class, the 201.
Thing. But it is weird. It's very different than what we normally do, this section. So we won't do this. This is really not that important of a section because we won't do much of this in the rest of the class. I'll let you know when things really matter. This isn't huge. We won't really do much more of this throughout the semester, this stuff. It's kind of a unique thing. So domain. What do they mean domain? What's that? It's kind of a weird thing. Domain means, well, we already had domain on a picture a minute ago, right? Yeah, you're probably thinking, well, we know domain. Domain is left edge, right edge. Well, yeah, on a picture, yeah. Because what domain means is left edge, right edge, that means x-axis, doesn't it? So domain means x values. Left edge, right edge, that's width coverage, that's x values, right? On a picture. And that's what it means here. Domain means possible x values. The problem is on this question number 6 here, I don't have a picture. They're not giving me a picture. They're just giving me a function, an equation. Well, it's not really an equation, a function. They're giving me a function. They're not giving me a picture of it. If they gave me a picture, I would just go left edge, right edge, got it, I'm done. Because that would be the x coverage, the width, the left edge, right edge. But they're not giving me a picture. They're just giving me that little function. So how do I find the possible x values if I don't have a picture to just go from here to there, left to right? I don't have a picture. Well, you just simply look at the thing and you just ask yourself, what could I put into that thing and what could I not? I know it's weird. Let me just jump to the actual deal. You take the denominator, which is this, 3 minus 4x, and you say, denominator, you cannot be 0. Not equal. That's a not equals. Why not? Why can't the denominator be 0? Do you know dividing by 0 is like the big no-no in math? Because it's not real. Do you know what I mean? Because this guy, I shouldn't say that way. I should say it has no counterpart in the real world. You know what I mean? Like if you take any number, let's say 5 divided by 0, what is that? Well, it's nothing. You can't do that. Am I confusing you? I want to make sure this is real for you because you'll remember it better that way. If I had 1 whole pie, you know what 1/3. If I say, hey, last night I ate 1/3 of the pie, you know what that means, right? That's real life. There was a pie. It looks like a peace symbol. It was cut into 3 pieces, and I ate 1. That's 1/3 of the pie. We know that. That's real life. Okay. What would it mean if I said last night I ate 0/3 of the pie? That's just a weird way to say you ate no pie. But you could say it that way, right? That'd be weird. But technically you could do that. You could say I ate 0. That means there was a pie. It was cut into 3 pieces, and I had none of them. It's just a weird way to say 0. So 0 in the top is fine. It's just 0. It's weird, but it's fine. Now, what would it mean to put it in the bottom? 3/0. You can't do that. Remember, the bottom is the number of pieces it's cut into, right? Cut into 0 pieces? How do you do that? How do you take a pie and cut it into 0 pieces?
You leave it whole.
If you leave it whole, it's 1 piece. If you don't touch it with the knife, it's 1 piece. It's not 0 pieces. I got a pie, it's 0 pieces. No, it's 1 piece.
Then you eat it.
Yeah, you can eat it, but you still don't have 0 pieces. You never have 0 pieces if you got a pie, right? There's no way to cut any real life object into 0 pieces, right? That's not in the real world. You can't do that. So that's why in fact, what we say is it's undefined. What we mean by that, we mean there's no connection to the real world. You can't do that. You can put numbers there if you want, but that means nothing in the real world. Right? In the universe in which we live, you can't cut something into 0 pieces, right? It's impossible. So that's why we never want 0 underneath a fraction. That helps you remember it. Underneath, undefined. You can't have it. So what that means is, going back to our question, we do not want to let x be any number or that would make this denominator 0. We don't care about the 7. 7 is irrelevant to us. The top doesn't matter to us. But the bottom, if they're asking me domain means what x values are allowable, acceptable, okay, well, any x values are okay. Plug in anything you want as long as you do not let the bottom equal 0. Well, how do you know what's going to do that? You solve for it like you would solve for any equation. So I take this little not equals equation and I solve for x. Here it is. How do I solve for x? What do I do first to solve there for x? X is saying, I want to be alone. So what do I do? Here's x. I want to be alone. Get rid of this 3 and this -4. So I can be alone. So what do we do first?
Multiply by.
You save the -4 for last. Remember, you save the thing right next to x for last. We'll divide that off last. First, you get rid of the stuff added and subtracted, right? So first get rid of that 3. How do I get rid of that 3? Subtract 3, right? And then we got minus 4x not equal to negative, right? 0 minus 3 is -3. You with me? And then x is saying, I want to be alone, so what's the last step? That's -4 times x, right? So divide it, yeah, divide by -4. Boom. So x, again, not equal. We're saying what x cannot be. And 2 negatives? Positive, regular. 3/4. So we're saying x cannot be 3/4. Because if what? Because if x is 3/4, it's going to choke that, it's going to make the denominator 0, which makes that fraction undefined. Makes it wacko. Can't do that in the real world. So that's why the answer is right here. X can be any real number, but it cannot be, it's not equal to 3/4. I know that's kind of weird. Not something we're going to do hardly any more of in the rest of the course. Does that make sense? Domain is just what's allowable, what you can plug in for x, when they don't give you a picture. So right, we have 2 domain things, right? Domain with a picture, left edge, right edge. Domain with no picture, just make sure the denominator doesn't equal 0. So as long as x is not 3/4, as long as it's anything but 3/4, it'll be okay. Right? Do you see how it works, guys? Maybe this would help. Do you see if you let x be 3/4? Do you see how it would cause a problem? Right? See what it would do? Let me work it out to show you. 3 minus 4 times 3/4. See how that would be a problem? These 4s would cancel, and you would have 3 minus 3, 0. That would make the denominator 0, which would choke the thing. You can't have 0. You can tell your calculator, take any number, divide by 0, it'll go air. You know, you can't do it. It's meaningless stuff. So these will be cake now. Let me show you. These will be 2 seconds.
Stuff on the test?
There'll be one. There's one of everything.
Okay, one weird.
You know where it won't be on the final. Because we'll never do this again. Things on the final are like main things, and this is not a main thing. So yeah, so how do you handle domain? So let me be real straight ahead then, because I know I've kind of been here and there and back and forth. Domain with no picture. Let me be crystal clear. I can't spell picture. Domain when there's no picture, no graph. What do? You take the denominator not equal to 0 and you solve. Number 1. Number 2, if there's no denominator, like this one, then the answer is any number. So there's the game plan for how you handle domain when there's no graph, no picture. So we look at this function,
It's a real number.
yeah, it's not as opposed to a fake number. Yes. So our question is P of x equals x squared plus 6. Does that have any denominators?
No,
No denominator,
so it's any number.
no problem. No denominator, no problems, any number. So we just grab option D here. Any real number. So those are just instantaneous. If it doesn't have a denominator, then it's got no trouble spots. Does that make sense? We're just looking for trouble spots, and the only thing that could choke it, could cause a problem, is if there's a denominator, and if so, you got to make sure that denominator doesn't become 0, because that's meaningless. If it's got no denominator, it's got no problem. It's any real number. Yeah.
Okay.
Car.
You have number 1 denom and
Yeah, what is that?
what is that word?
I thought it was written so clearly. No, I'm kidding. I'm a scribbler. Solve. So denominator not equals 0, then solve. It's like the light is. Oh, it's like I turned on the lights all of a sudden. All right, yeah. Then solve. Yeah, denominator not equal to 0, then solve it.
And
Sorry
Yeah.
for these guys, they missed your whole Costco explanation from last semester.
We'll get into Costco this semester. We'll get into that. We're going to redo most things. All right, we good there? So basically, if they don't have a denominator, they're just just snap through those. You know, you'll have I think they give you 2 or 3 of those. Those will be really, really easy. If it has a denominator, then just grab the denominator not equal to 0 and solve it. If it doesn't have a denominator, it's just any real number. That's for domains with no picture. Do you see how I'm trying to key in your mind what to do when? That's a lot of what you want to do for yourself as you get ready for the exam September 6th, is you know, a lot of doing well on a math test is identification. You want to just have in your mind, okay, if I see a domain with a graph, I'm going to go left edge, right edge. If I see a domain with no graph, I'm going to look for a denominator. If there's no denominator, it's all real. You want to, have a plan for different kinds of problems. That's what you want to do. And you have a 3x5 card, you can write as much of that on there as you want. Okay, so they're going P of x, make it a little bigger here, absolute value of x minus a, and they're asking me domain. Notice they're not asking me to graph it. They're not asking me to do all kinds of things they could ask me to. Didn't we graph some Monday? Right, with the V, there were the V's, right? Mm-hmm. We graphed some, yeah. Anyway, they're not asking that now, so I hope that's not confusing your mind. They could say, hey, graph this, and we did some of that on Monday. Those were V shapes, but they're not asking me to graph it. They're just saying, find the domain. Find the domain. What's the domain? What do we do? We look and we say, is there a denominator? No. There's not. All reals. All real numbers. There it is. Done. There's nothing to do. It's just identification. These will be your favorite homework questions.
It's kind of easy, but it still kind of doesn't make sense.
Doesn't make sense? So what we're saying is, you can put any x value you want into this function. Let me make a little more sense of it. That's what we're saying. It's kind of like, what if I had a toaster? Let me make it a little more real. A toaster is kind of like a function. There are certain things you can put, and certain things you can't into the toaster. Or the microwave, right? Microwave. I had my daughters throwing tinfoil in the microwave before. Threw tinfoil in there, started it up. My son and I leaped for the microwave and said, no, 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 no. Don't put, right? Or you shouldn't put knives in the toaster. So those would not be in the domain of the toaster or the microwave. Does that make sense? Domain is acceptable inputs. What you're allowed to put in. That's what domain is. What you're allowed to plug in. So you can put anything you want in the microwave, but not tinfoil, right? You can put anything you want into this function. He's got no problems. But over here, this one has an issue. You can't put in 3/4. That's going to cause a problem. Anything else is fine. That's what we're doing. We're just finding out what's in. So number 9. So g of x equals 8 over 8 minus 5x. 8 minus 5x. What's the domain? So try that one.
You see, but the thing is I understand how to do the math, it's just, when you put the math together with the words, it's kind of confusing. It's like, I get the right answer, I know how to get the right answer at least. It's just, I don't know when I'll ever use it.
Yeah, you have to go a little higher. Pre-calc, you'd see some real life.
I'm going there.
So you will, those questions will be answered. All right, so all we do is we grab the denominator. Don't even regard the numerator at all. Don't care about that at all. Just grab the denominator. Say, hey, denominator, you cannot be 0. Right? Is that good? We're not allowing the denominator to be 0. And then you just solve that thing. Solve for x, and I won't be alone. Get rid of this negative 5, get rid of this 8. Who do we get rid of first to get x alone? Yeah, start on the outside, right? Always get rid of the outside and save the negative 5, the thing right next to x for last. Divide that at the end last. So first thing is get rid of that 8. So subtract 8 from both sides. And that's gone. So we get minus 5 not equal to negative 8. Minus 5x not equal to negative 8. That okay? I'm being a little scribbly here. And then last step to get x alone, divide by minus 5. 2 negatives, positive. X cannot be 8/5. That's answer B, isn't it? X can be anything but 8/5. You can't put 8/5 into that function. It's like putting tinfoil in the microwave. It'll cause a problem, but anything else is fine. That's the only trouble spot. Is that good? Questions on that? We're back. All right, P, can you read it? P of x equals x to the third minus x squared plus x minus 2. What is the domain of that function? All reals. Done. There's nothing to do. There's no domain. I mean, there's no domain. There's no denominator. There's no denominator. So all reals. All real numbers. Everything's fine, right? You can plug anything you want into that. He's got no problems at all. Nothing will choke him. Anything's fine. All real numbers. Simple, simple, right?